welcome to the deep dive. Today we're looking at, well, a really remarkable weather story. A hurricane, unbelievably powerful, crosses the Atlantic and then sort of reinvents itself.
Yeah.
Completely changes Europe's weather in ways maybe people didn't quite expect.
That's right.
Our mission is to figure out how this storm, Ex-hurricane Erin, became this kind of hidden threat. Okay, let's unpack this.
What's fascinating here is, Erin wasn't just any hurricane.
Right.
It kicked off as the season's first Cat 5, the most powerful one globally at that point in 2025.
Wow.
But the real story is this profound metamorphosis it went through. It turned into this huge, energetic, post-tropical system.
Okay.
And that left a very unique, kind of unexpected impact signature on Europe.
And that origin, I mean, it was explosive, wasn't it?
Yeah.
Our sources show on August 16th.
Unbelievable intensification.
Yeah, just 12 hours, Category 1 to Category 4, kept going to Cat 5.
160-mile-per-hour winds.
And that pressure, 915 millibars,
Yeah,
I mean, that's just,
yeah,
that tells you everything, right?
absolutely extreme. The most intense cyclone globally up to then.
But even way out there, it was causing problems.
Right.
Big swells closing beaches from the Carolinas up to New York.
That's right, yeah. That energy travels. But that transition you mentioned, it's key. It's not decay.
Okay, so not just fizzling out.
No, not at all. It's a radical change. Think metamorphosis. It ditches its warm tropical core, its engine,
Right.
and it taps into something called baroclinic instability. Essentially, drawing power from colliding warm and cold air, a totally different fuel source.
So it becomes a different beast entirely.
Exactly, a fully fledged, potent North Atlantic storm, not some weak remnant. And the jet stream, the North Atlantic jet stream.
But a roll.
Oh yeah, a critical role. It grabbed Erin, strengthened it even more, and basically steered it right towards Europe.
So this transformed powerhouse arrives, and Europe's having this lovely late summer.
Yeah, warm, dry, really nice weather. There's this big high-pressure system giving the UK temps up to like 30 Celsius. Very. But Erin coming in just eroded that completely. Abrupt end to the warmth.
And that existing warm air didn't just disappear?
No, and that's the interesting bit. That warm, humid air. It actually became a key ingredient for the incoming storm.
Ah, so it fueled the rain.
Precisely. When Erin's cold front pushed in, all that moisture got wrung out, intensifying the precipitation, so the heat wave kind of primed the pump for heavier rain.
Right, okay. And we saw that, didn't we? Widespread rain, blustery winds across the British Isle.
Scotland and Northern Ireland got hit pretty hard, 50, 80 millimeters in places.
Even southern Iceland saw severe winds. But you're saying that wasn't the main story. Here's where it gets really interesting.
Exactly. That wind and rain, while impactful locally, wasn't the biggest danger overall. The real issue was Erin's immense wind field out over the Atlantic.
Okay.
It generated this massive, long-period ocean swell, huge waves traveling thousands of miles.
Long period meaning?
Meaning lots of energy packed into each wave, traveling very fast, very powerful, even far from the storm itself. We're talking forecast wave heights of like 8 to 10 meters along Western Ireland, the Outer Hebrides.
10 meters, that's enormous.
Huge. And this creates incredibly dangerous coastal conditions. Powerful rip currents, hazardous surf, not just Ireland and the UK, but France, Spain too.
And that's the deceptive part you mentioned.
That's the key takeaway. It's this deceptive threat. You could have relatively calm local weather, maybe even sunshine on the coast.
Right.
But this incredibly high energy swell, born from a storm hundreds or thousands of miles away, arrives almost silently from the sea.
Wow.
So the greatest risk to life in this case wasn't the wind you felt, but the immense energy rolling in from the ocean.
That's genuinely chilling. A clear sky, but deadly waves. How does this stack up against, say, other big post-tropical storms we've seen hit Europe?
Well, if you think back, Ex-hurricane Ophelia in 2017, that was primarily remembered for its destructive winds. Really damaging gusts caused fatality.
I've heard that one.
Yeah. And Lorenzo in 2019 also brought severe winds, particularly to the Azores and Ireland. But Erin was different.
How so?
Its unique signature, that's main impact, was overwhelmingly that massive, hazardous ocean swell. It stands out as a marine-dominant event for Europe. Less about the wind hitting land, more about the energy hitting the coastlines.
So what does this all mean? Looking back at Erin, it's like a masterclass in atmospheric transformation, isn't it?
Absolutely.
It shows how a hurricane's energy can cross an entire ocean, change form, and then profoundly reshape weather and, crucially, coastal safety on another continent.
And it wasn't just the storm itself, but its far-reaching consequences, the swell.
Right, the stuff you don't always see coming.
Which I think this raises an important question for you, for everyone listening, really.
Yeah.
How often do we maybe overlook these silent threats, like a distant ocean swell, because we're focused on the more obvious hazards right in front of us, like wind and rain?
That's a really good point.
The true power, the real danger of these massive natural systems isn't always where we first expect to find it. Sometimes it arrives quietly from far away.